Okay. So this is the homework number 3 discussion in CE 528. So this is sort of what I was trying to get at when I asked you to look at that Honda Civic problem. And then this is what the problem looked like. Develop the cost functions. So we were given how the labor and capital come together to produce a certain number of cars. And I gave you some unit price for labor and capital. And then the labor was 5,000 per unit and capital was 10,000 per unit. And then we wanted to derive the average and marginal cost per vehicle produced. But before we can do that, we had to derive the actual cost function first. So to get started on that, I asked you to create some isoquants, and those isoquants could be created by assuming a certain number of cars being produced, so 10 cars. So combinations of labor and capital that'll produce that. So what I did was I just took these different numbers of labor, because remember Q was equal to L raised to power half, C raised to power half. So if I square both sides of that equation, what I'll get is, and I'm going to go ahead and annotate that. So if I square, so the equation that was given to me was Q equal to L raised to power half times C raised to power half, right? So if I square both sides, I'll get Q raised to power 2 equal to LC. And I can derive that equation, and I can create that equation into C equal to Q squared by L. Okay, because so I'm trying to bring that equation in the form of Y as a function of X. And remember, if you recall from our discussion, that our C is on the Y-axis and L is on the X-axis, right? So I'm trying to write this equation as if I'm trying to write that equation as Y as a function of X, right? So I'm trying to write it as Y equal to F of X. So this is how I'm trying to write that equation. And because my Y-axis is C, so I'm going to write it as C equal to Q squared divided by L. Okay, so my C becomes Q squared divided by L. And I sort of take that formula and I just took some numbers to create some isoquants here. Okay, so if you look at here, I set L equal to 1, 11, 21, so forth like that. And then if you're producing 10 cars, so C will be Q squared, so B11 times B11, which is the number of cars. As you can see, B11 is this cell right here. And then times B11 divided by D10. Divided by D10 will be the L value. And again, I didn't have to do 1, 11, and so forth. I just chose whatever numbers. So if you do it, and you do it for 20 cars, 30 cars, 40 cars, and 50 cars, this becomes Q squared over L. And when L is 1, it's basically just the Q squared values here. And then as L increases, the amount of capital that you need to produce the same number of cars goes down. Like if L goes to 131, you only need C equal to 19.1 to produce 50 cars per day. Okay. Now, then I basically plot these series, C and L. So if you look at any of these series that I'm plotting here, look at the definition of any of these isoquants. It's a weird sort of thing, but because it's coming from my, but you have to look at D15 to Q15. Okay, so D15 to Q15, I'm plotting D15 to Q15. Basically, that's your, on the x-axis is that. And then I'm plotting that against the L value. Okay, I'm plotting that against C50. So basically, if you look at sort of series, so this series definition is this is file path. But if you look at C15, and then D15 to Q15, right? So that's what's going on. So C15 essentially provides the name here. D10 to Q10 provides the L values. D10 to Q10 provides the L values. So you can see that it's kind of hidden in this very big file name, but you could see it, what I'm highlighting here. So D10 to Q10 and plot it with D15 to Q15. And this is what you get out of that. And then you could create those isoquants. You can create those isoquants for all these different values. And I see 5 of them. Now, once you create that, does that make sense for everybody? These isoquants creation, how we came up with these isoquants? Any questions? Okay, so just let me real quick. I wrote down the equation Q square over L in the C equal to Q square over L. And I did that because C was on the y-axis. So this, I'm writing it as a y equal to fx format. And then I took the derivative dc over dl, which will be negative Q square over L square, because Q is a constant quantity for my isoquant, for any given isoquant. And then 1 over L will have a derivative of minus 1 over L squared. And then if I look right down the equation of my budget line, so this is the equation of my isoquants, the top line. Okay, and then this is my budget line. So when I did that, I took the derivative and I got this minus Q square over L square. And for budget line, this was my equation. It's an equation of a straight line. So you should be able to tell me what's the slope of this straight line, or the dc over dl based on this. I see one response in the chat, which is correct. Anybody else wants to chime in? Yeah, dc over dl is negative 5 over 10. That's right. So I could say negative 5 over 10 is the slope of this line, which is nothing but negative half, right? Now, if I'm looking for that expansion path, I told you, and we know that from the Excel sheet, that we are looking for where my budget line is tangent to the isoquant, right? And how do I get that? I get that by equating these two slopes. So I say, wherever minus Q squared raised to power 2 minus Q squared over L squared equal to negative 1/2. That would be the equation of my isoquant. Now, the only trick that remains now is that for the expansion path, I want that equation in the form of LC still, right? I want that equation in the form of L, labor, and capital axes. So how do I convert? This is not in the form of LC though, right? This equation that I'm highlighting on the whiteboard is not in the form of L and C. It still has the Q term. Is there anything else that you could do it to simplify it so that the equation that I get is in the form of L and C, is in terms of L and C? How do I do that? Any thoughts? The recording. So I got some response here on the chat there. That's pretty good, which is I can take this Q square because I know that Q square from this equation, from my isoquant, Q square is equal to LC. So I can actually write down this equation, simplify that equation into like this. I can replace Q square with LC divided by L squared. And then that would be equal to minus half, not minus half, just half, because minus would cancel out as well. And then if you further simplify it, this is what you end up with. C divided by L equal to 1 divided by 2. And essentially that becomes, okay, that becomes L equal to 2C. L equal to 2C. Okay, so this becomes my expansion path. Is everybody clear on this derivation here? So your optimal expansion path is when you have labor equal to 2 times the capital. That's your optimal expansion path. This is the path along which you should be expanding. Now you know the price of each of those quantities, and you can also figure out if you want to write, and you also know the price of labor and capital as well, right? You know the price of labor and capital. So you can convert this information that labor equal to 2 times capital is your optimal expansion path. You can then convert this information into what we call the cost function. And how do you do that? So let me go ahead and stop sharing the white function, or I'm sorry, the whiteboard. And let's go back to the Excel file. So once you figure out that L equal to 2C is your expansion path, okay, so this is what that path is going to look like. L equal to 2C. And if you sort of draw that line out, you can see here, you can almost see that these points are, so if you especially look at where the tangent lies, if the tangent lies exactly on the curve, you end up with that curve here. Okay, so this is what you've gotten now. Once you have that, once you've gotten that, then you can start looking at if your budget is 0, 290, 430, 570, 710, like you had here. Okay, you can figure out what the L is going to be and what C is going to be. Okay, okay, so you could figure out if your budget is 290, your L is 29, and then you can, based on that, you can figure out the C, and then based on that, you can figure out the Q. Okay, and once you know the Q, total Q produced, okay, you can also figure out what the C is and your cost of producing. So you can then figure out, you can then plot out this Q function, and that I'm going to highlight here, and then the total cost function that I'm going to highlight here. So once you plot these two things out, because then in this case, your budget becomes your total cost. And then based on that, you can figure out how many quantities of Honda Civics will you be able to produce. And then you could chart those two columns out. You can even chart the budget column. It's the same thing as cost, right? Because you're essentially figuring out and remember, the key thing is to figure out what that optimal expansion path look like. The expansion path would be where L is equal to 2 times C. So you could see that when I'm at 21.4, 21.5, my C will be 43. You know, you could take any combination. You can even start off with some L and C combination. So you can also get to that production function, the total cost function, using this technique where you have L and C. Okay, so you can just start out with any value, 0 and 0. And the equation is 2 times C, right? L equal to 2 times C. So all you do is equal to 2 times C. Okay? And then you can just plug in some values of C. So 0, 10. And then you can drag this out. And then you can drag this formula out as well. Okay. And then based on that, you could figure out the total cost. The total cost will be 5 times L plus 10 times C. So that'll be a total cost. So you can write down that total cost in terms of dollar amounts. Okay. And then number of cars produced is pretty easy because it's just L raised to power half and C raised to power half. So equal to this multiplied by this, and then the whole thing raised to power half. And then you could drag this out as well. Now, if you were to chart, oops, did I? Oh no, not 2. I'm sorry. It should be 0. Okay. So you could see that I could then create. So this is my total cost building the cars or manufacturing the cars. And then this is the number of cars. I've gotten Q and C, so I can put total cost on the y-axis and number of vehicles produced on the x-axis, and I'll get the exact same line. I'll get the exact same line if I were to chart out these two columns. I'll get the exact same line. Any questions about this? I know it's a little bit complicated, so I will definitely encourage, regardless of how many points you got on the homework. Most of you got good points, and some of you even got 100 points. But I'll still encourage you to look at this solution sheet that I provided and make sure that you can understand everything about this. Are there any questions at all about this at all? Go ahead and pause the recording.